Hello, you're very welcome to this video called Time for Some Roots. Sounds a bit like eating your vegetables. Maybe it will feel like that when we're finished. I'm Seamus Ballew at Dundalk Institute of Technology, and this video is for first year science and electronics students. So we'll make a start. So you see those square root symbols along there, and you're probably all very familiar with those numbers. So in this video, we're going to look at squares and square roots. So for example, we have 5 squared, 5 to the power of 2 equals 25. 6.7 squared is equal to 44.89. 5 squared can also be written as 5 times 5 equals 25. 6.7 times 6.7 equals 44.89. So 5 squared equals 25. We can view that graphically as a square where each side is 5 units in length. And when you go 5 fives are 25, the area is 5 square units. So supposing we regard each of those units as a centimetre, that length is 5 centimetres, that length there is 5 centimetres, and the area is 25 squares, where each side of the square is a centimetre, 25 square centimetres. So what is the square root of 64? So that's the symbol for the square root. So basically, if we've got a square and the area is 64 centimeters squared, let's say, what's the length of each side? Well, obviously, I think you know the answer. The square root of 64 is equal to 8. In other words, we have 8 units along the length there and 8 units there, and again 8 eighths are 64, giving 64 square centimeters. Now the square root of 64 is equal to 8, but the second answer, the square root of 64, can also be equal to minus 8. So 8 and minus 8 are two different numbers, even though one is the plus version, the other is the minus version. So if we're trying to solve a simple equation, something like this, t squared equals 49. Evaluate t. So you probably know how to do this from your intuition from school, but let's just tease it out a wee bit. So what we're going to do is we're going to take the square root of each side of this equation. And the question is, why do we do that? So if we just look at a number example, just to get to the background. Now this is different from the 49 question there. So if we look at 8 squared, we remember that 8 squared is equal to 64. Now what is the square root of 64? The square root of 64 is equal to 8. Now we also mentioned minus 8, so you generally write that as plus or minus 8. But just here we'll concentrate on the plus answer. And as you know, when there's no sign in front of the number, we assume it's plus. Now the interesting thing here is, what do you notice? If you take the square root of 8 squared, you're left with 8. In other words, the square root function is a kind of an opposite function to the square. The square root cancels out the square. In mathematical terms, we call this that one function is the inverse of the other. So it doesn't matter what the number t is. So if we have the square root of t squared, then when you take the square root of t squared, you end up getting your answer t. So in this example here, the value of t was 8. The square root of t squared is equal to 8. And there's the t there. Likewise, the square root of 13 squared would be equal to 13. Doesn't matter what number t is. This is always true. If you have t squared, you take the square root, you get t. And this is very important for us. So back to our question. And now remember this here, this is going to be important. We won't keep writing this out. That if you have t squared, you do the square root of t squared, you get t. So what we're going to do here is we're going to take the square root of both sides of this equation. And as you know, the square root of t squared just gives us back t. And the square root on this side is 49. So t equals plus or minus 7. And you can write it out as two separate answers. T is equal to 7 or T is equal to minus 7. And you can check your answer. T squared equals 7 squared, which is 7 sevens equals plus 49. T squared is minus 7 squared equals minus 7 times minus 7, and it's still equal to plus 49. Now, here we're going to start with the square root. So, for example, if we have the square root of 49, you remember the square root of 49 is equal to 7. It's also equal to minus 7, but we'll concentrate on the plus again. Now, what we're going to do this time is we're going to take the square root of 49 and we're going to square it. And let's see what happens. Well, the square root of 49 is equal to 7. And if you square 7, you get back 49. So again, you see that the square is the inverse of the square root. So the square function sort of cancels out the square root function, and we're left with 49. So likewise, if we have the square root of t and we square it, we just get back t. And this works for any function. So squaring a square root cancels out the square root, as it were. So again, always remember this. If you have a square root and you square it, you get t. So again, to summarize, the square root of 49 by the square root of 49 is 7 times 7, which is equal to 49. And likewise, root t by root t is equal to t. And that's just the same as the square root of t all squared equals t. So here's a wee example for us. Again, just remember this here. Again, we won't write this out every time. If you square a square root, you get t. So for example, if t equals 6, find t. Now, a wise student in an exam once did something like this. They wrote out, here it is, and they brought an arrow up and they showed us where t was. And they got full marks for the question. Right, back to the question in hand. If the square root of t is equal to 6, find t. So we want to undo the square root. What's the opposite function to the square root? The opposite function to the square root is the square. So we square both sides. And you know if you square a square root, you just get back t. And then we square the right hand side and we get 6 squared. T is equal to 6 squared. T is equal to 36. So here's a few questions to try. So for A, B, C, D and E, find y in each of the following. If the square root of y is equal to 5.7, find y, find the value of y. If y squared is 6.7, find the value of y. Part C. If y squared over 3 is equal to 5.6, find the value of y. Part D. If 3.8 divided by the square root of y is equal to 1.8, find the value of y. Part E. If the square root of y is equal to minus 13, find the value of y. So part A. Square root of y is equal to 5.7. And I think you'll remember how to do this now. What's the opposite function or the inverse function to the square root? It's the square. So we square both sides in this expression, and you know that when you square a square root, you cancel out, or the inverse cancels out the square root, and we're just left with y. So we square both sides. Squaring both sides, y equals 5.7 squared, y equals 32.49. Part B. Y squared equals 6.7. Again, we want to get y on the left hand side. What's the opposite function to the square? The opposite function to the square is the square root. So we take the square root of both sides. And on the left, we'll get y equals. So square root both sides. Y equals the square root of 6.7. Y equals, and there are two answers when you take the square root, plus or minus 2.588. So in this example, part C, y squared over 3 equals 5.6. You'll remember from the mathematical tools video that when you cross multiply, y squared equals 3 times 5.6, giving you 16.8. Or you can view it this way, y squared over 3 equals 5.6 over 1. Cross multiplying, y squared is 3 times 5.6, which is 16.8. So y squared, 16.8. take the square root of both sides. Y is the square root of 16.8. Y equals 4.099. Part D. 3.8 over the square root of y equals 1.8. Again, similar to the last example, 3.8 times 1 equals 1.8 times the square root of y. So there we are, 1.8 times the square root of y equals 3.8. Now, if we recall from an algebra technique that we had as well, if we just come down to this example for a minute, supposing we had 1.8 times w equals 3.8. So imagine w to replace the square root of y. So if you're solving this equation here, remember what we did to find w. 1.8w is 3.8. W equals 3.8 divided by 1.8, and that's equal to 2.11. So likewise up here, to find the square root of y, we divide both sides by 1.8. So the square root of y equals 2.1. That is 3.8 divided by 1.8. And again, how do we undo the square root? Square both sides. Y equals 2.11 squared. Y equals 4.45. Square root of y equals a minus 13. Now this is an example that kind of intrigues students sometimes. We square both sides. So what happens when you square both sides? Y equals minus 13 inside a bracket all squared. So y equals plus 169. Sometimes in error, the student using a calculator might just go minus 13 squared, and it does the 13 squared bit first, and you end up with an answer minus 169. But it's minus by minus. So y equals minus 13 all squared. Y is 169. Here's a few more examples. You might like to pause the video and have a go at doing the parts from F down to part L. So in F we have 5 times the square root of Q is equal to 56. Part G, 8.7 times Q squared equals 81.6. Part H, square root of 5Q equals 56. Part I, 8.7Q all squared is 81.6. Part J, Q squared over 8 equals Q over 2. Part K, 3Q plus 7 all squared is 27.4. Part L, square root of 5Q plus 6 equals 56. And in all these examples, find the value of Q each time. Part F, 5 times the square root of Q is equal to 56. Again, instead of taking the square root of Q, suppose we just called it H. How would you have solved 5H equals 56? H equals 56 divided by 5. H equals 11.2. So here, the square root of Q is equal to 56 divided by 5 equals 11.2. So to undo the square root, we square both sides. So Q equals 11.2 squared equals 125.44. Part G, 8.7Q squared equals 81.6. Again, instead of Q squared, if we had 8.7H equals 81.6, H equals 81.6 divided by 8.7 equals 9.38. So for 8.7Q squared equals 81.6, Q squared equals 81.6 divided by 8.7 equals 9.38. So we square root both sides. Q equals the square root of 9.38. Q equals plus or minus 3.06. Part H, the square root of 5Q. So it's the square root of both 5 times Q. So 5Q is under the square root sign, equals 56. Square both sides. 5Q equals 56 squared equals 3,136. And then we divide by 5, divide both sides by 5, q equals 3136, divide by 5, q equals 627.2. Part I, 8.7q all squared equals 81.6. To undo the square, we take the square root of both sides, and that undoes the square on the left. So we get 8.7q equals the square root of 81.6. 8.7q equals plus or minus 9.03, and then we divide by 8.7. So q equals plus or minus 1.038. So here we are, part J. Q squared over 8 equals Q over 2. So you might spot an answer, or if we just carry on and do the cross multiply for the minute, Q squared times 2, that's 2Q squared equals 8 times Q. So looking at this equation here, or the original question, when you get experience at looking at these things, you sort of spot that if Q is equal to 0, what would happen? What's 0 divided by 8? It's 0. And if Q is 0 on this side, 0 divided by 2 is 0. 0 equals 0. That means Q is equal to 0. Likewise here, if Q is 0, 2 times 0 squared is 0 equals 8 times 0. So Q is equal to 0. So that's an answer to this question here. But there might be another answer, because when you got a q squared, remember when you have a q squared, sometimes you do a square root and you end up with two answers. So because of the square, we expect a second answer. So to get that second answer, we just take this equation here, divide both sides by 2, and we get q squared equals 4q. And then what we do, this is a new experience for us, we can divide both of these sides here by q. And we can assume that q is not 0. We already know q is equal to 0. So we're dividing by the non-zero answer for q. So q squared is the same as q times q. But if you divide by q, you just get a single q. And what's 4 times q divided by q? It's equal to 4. So q is equal to 4. Or the second possibility for q was that was equal to 0. And again, just to clarify that there about the q squared divided by q, q squared over q is the same as q times q over q. And if you want to do a number example, 8 squared over 8 is 8 times 8 over 8. And you know that 8 by 8 over 8, that's the same as 64 over 8 equals 8. So the q on the bottom divides into one of the q's on the top. So you're left with the other q. And part K, 3q plus 7 all squared equals 27.4. Square root both sides, undoes the square on the left hand side, and we're left with 3q plus 7 equals the square root of 27.4. 3q plus 7 equals plus or minus 5.23. That represents two answers. So we can write out these two answers separately. 3q plus 7 equals 5.23 or plus 5.23, or 3q plus 7 equals minus 5.23. So these two equations now need to be solved to get two different answers for q. So if we look at the equation on the left hand side, 3q plus 7 equals 5.23, and we take 7 away from both sides. So 5.23 take away 7 is minus 1.77. So 3q equals minus 1.77. Divide by 3, q equals minus 0.59. And then the equation on the right hand side, 3q plus 7 equals minus 5.23. 3q equals minus 12.23. We take 7 away from both sides. Q equals, divide the minus 12 by 3. Q equals minus 4.06. So finally, for this question, 3q plus 7 all squared equals 27.4. We have the two answers. Q equals minus 0.59 or Q equals minus 0.46. So our final part, part L, the square root of 5Q plus 6 equals 56. To undo the square root on the left hand side, we square both sides. 5Q plus 6 equals 56 all squared, which is 3,136. 5Q plus 6 equals 3136. We take 6 away from both sides, leaving 5Q on the left hand side equals 3,130. And then to find Q, we divide 3130 by 5. Q equals 626. We hope you've enjoyed the roots and squares, and that concludes Time for Some Roots. Thank you very much.